Hey again, it's Mr. Lum, and we're going to do some more electrochemistry, and we're going to talk about half cells and what happens if they're not at standard state. Okay, so let's do a quick review on what is standard state. So standard state is when standard state, let's write it down here. Standard state is when you have a concentration of a solution that is 1.0 molar. Okay, so for example, if you had Cu2 plus right here, or maybe say like take example maybe this one right here, Cu plus, we had something like CuNO3 or Cu2 plus like maybe CuSO4. So this concentration will be 1.0 molar, and then it's at standard state. If we were dealing something that's like a gas, like hydrogen gas, then it would be at 101.3 kilopascals. Okay, that would be the pressure of it. So concentration pressure, and again for concentration, the solution and everything would be at a temperature of 25 degrees Celsius. This is at standard state. If you change some of these things, then it's no longer standard state, and that means we can no longer use these numbers in calculations. So let's talk about changing some of these numbers so that it's not at standard state. So let's take an example like this one right here, CuNO3. NO3 is just a spectator, so it'll just be Cu plus plus an electron, making Cu solid. Okay. Now this has a reduction potential that is at 0.52. Okay, positive 0.52. Now if we change it so it's no longer at standard state, not at standard state, then like maybe we increased it to 2.0 molarity. So what we'd be doing is we'd be increasing this concentration right here. And the potential for it to gain electrons, okay, or its reduction potential for gaining electrons is greater if we increase the concentration. Since it's greater, this number is going to be increasing. Now, same thing if we decreased it. If we decreased this, then its reduction potential is going to also decrease. Okay, so if we decrease this, then this number is going to be less than 0.52. If we increased it, it's going to be greater than 0.52. Okay, so these are things, some trends that happen when it's not at standard state. So again, we can only use these numbers when it is at standard state here. So what does that mean? Well, let's take a look. So here is an equation that we did last time, and if you remember a very easy formula, we went E naught cell equals cathode minus anode, and we found that this is minus 0.13 minus negative 1.66, which left us with an initial voltage of 1.53 volts. Okay. So again, PB, if we look right here, PB is, as it moves in this way, its oxidation number is decreasing. Okay, therefore it's reduction, therefore this is the cathode. So I'm just going to write here, this is the cathode. And in this example right here, this one, the oxidation number is increasing, therefore it's oxidation, and therefore it's the anode. Okay. Now, let's take a look at, say if we add everything into here, and the reaction starts to go, and the initial voltage of our cell is 1.53. Now, as the reaction starts to proceed, it is a one-way reaction. It is going forward, and the concentration of Pb is decreasing. As this reaction goes forward, the concentration of Pb starts to decrease. So, when the concentration of Pb starts to decrease, this number also starts to decrease. So, Pb decreases, this number starts to decrease. So maybe it starts off at maybe 0.13, and then the reduction potential is also decreasing, is also getting a little bit less. So the reduction potential is decreasing, and maybe it turns into something like minus 0.45. I don't know, I'm just making some numbers up here. And for this one, aluminum starts to increase. The concentration of aluminum starts to increase, and that makes sense. Aluminum solid is turning into aluminum ions. So the concentration of aluminum ions is increasing, and therefore the tendency to reduce is also increasing. This reduction potential right here is also going to increase. So it's going from minus 1.66, and it's increasing. So a number that's bigger than that might be minus 1.20. Again, I'm just making some of these numbers up right here. Okay, and again, more Pb is decreasing, and therefore this number starts to get smaller and smaller. So maybe it's minus 0. And eventually maybe it gets down to minus 0.95 is the reduction potential. And this concentration is increasing and increasing, and therefore the reduction potential is increasing. And maybe this number increases to 0.95. So what we see here is eventually they're going to reach the same number. Eventually they're going to reach the same reduction potential. And if you take the E0 cell, cathode minus your anode, eventually your E0 cell, or your voltage, is going to eventually equal 0 volts. And that is essentially when it reaches equilibrium. When they both have the same reduction potential, or the same strength in reducing each other, that they have reached an equilibrium. And when this happens, your cell is producing no electricity, as we can clearly see right here. It's producing no electricity. Okay, and so that is the end of your electricity. And if you want to make some more electricity, well, something you can do is you can increase this concentration to back up, or you can take some of this concentration away. But whatever you do, if you don't do anything, then your cell is stopped producing electricity. Okay, and that's the end of your battery or your cell.